Hello everyone, I am Someshri Janapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So in this class, we will solve a numerical while a beam of naming A and AB is there, and here application of UVL you can see. You can see the UVL is here triangular in shape. So let's solve the numerical. First of all, we know the end supports will have reaction forces. Let's name it as RA and RB. As always, we will go for the calculation of step 1. Let's calculate reaction forces. Okay. So, how to calculate? We know that summation of all the vertical forces is equal to 0. So, here we will have RA plus RB minus. So, as this is the triangular shape loading, we can convert this loading to just we will need the area of the triangle. So, to calculate area, we will have half into the base of the triangle, you can see that is 6 meter, and the height will be your 10 kilonewton. So, here 2. So, we will have the equation as RA plus RB minus 30 is equals to 0. So, RA plus RB will be 30. Okay. Next, if we find out the movement according to point A, according to support A, okay. So, we will have the equation as RB into the total distance, that is RB into 6 is equals to, here we will have the centroid of this triangle, a distance of this is going to be a 2 by 3L, and here it is your 1 by 3L. So, here the load will be half into W into L multiply with the distance, that is 2 by 3 L. Okay. So, now RB value, W is 10 and L is your 6 into 2 into 6 by 3. Okay. So your RB value is going to be 120 upon 6. So we have the RB value here, that is 20. Okay. Now, if we just put this value here, we will have RA as 30 minus 20. This RA is equals to 10. Okay. Now we have the reactions here, RA and RB values. So here we have RA as 10 kilonewton and this RB as 20 kilonewton. Okay. Now let's go for the calculation of shear force. So while calculation of shear force, we will calculate shear force distance x from support A. Okay. So we will calculate shear force at distance x. So the load at this point will be this. Now you can see here we have two triangles. One is, let's name it as ABC and AOD. Now we have two triangles. As the slope of this triangle is same, so here we can put similar triangle rule. Right? So if it is similar triangle, so the small w, that is the weight here, W upon X is going to be your capital W upon L. So here the load will be Wx by L. Okay. Why we need this load? Because if we were calculating here the shear force, we need the force here. We need the load here, the small w. Right? So shear force at point X. What will be the value? It will be RA minus the load. So here the load will be what? The small triangle, that is the area of the small triangle, that is half into small w. We already have that w into here. We already have the this point load, that is Wx by L. So half into Wx by L into X. Now RA minus Wx square by 2L. Here is we have this equation 1. Okay. So now we can calculate shear force at any point. Let's find out shear force at point A. RA we already know 10 minus W into, here we will have X as 0. So shear force at A will be 10. Okay. Now shear force at point B. Let's check it. RA, let's put 10 minus X. X will be your 6. W is your, here W will be 10 into X, that is 6 square upon 2 into 6. Ten minus 30. So shear force at B will be minus of 20. We already got this value as RB. Okay. So we have now shear force at A and B. Let's draw the shear force diagram. First, so shear force at point B we have here, that is minus 20, and shear force at A we have, that is 10. Okay, as it is UVL, so our drawing will be very similar to like this. Right? So now we have one question. We will have one point where shear force is 0. This is our 0 point. We know also that when shear force is 0, at that point bending moment is going to be maximum. Okay, so now how to find out the distance of this 0 point? So how to find out this distance? Let's calculate. Okay, now we have shear force as 0. So if we put 0 in this equation and put all these values, so we will find out. So 0 is equals to 10 minus W is 10 into x square divided by 2 into L is your 6. So 10 is equals to 10x square by 12. 120 as 10x square. So x square will be your 12. X is equals to 3.46. So at a distance of 3.46, we will have 3.46 meter. We will have 0 as our shear force. Okay. So now let's calculate bending moment. So we know that at end supports bending moment will be 0. We will calculate bending moment at distance x. While x is equals to 3.46, we will find out bending moment at that point. Okay. So bending moment at x will be RA into x minus WX square by 2L. Okay. So in this triangle, you can see the load is acting here, but we need to find the centroid. So here it will be 2 by 3x and here it will be 1 by 3x as we are calculating from this point. So we need to multiply the load with this 1 by 3x. Okay. So this will be multiplied with 1 by 3 of x. Now let's put all those values, that is 10 into 3.46 minus W is your 10 into 3.46 whole square, 2 into 6. 3.46 by 3. Let's take it as 1. Okay. So now this will be 34.6 minus 3.46 multiply with 3.46 into 10. 119.716 by 12. So 34.6 minus 9.97. Here we have the answer, that is 34.6 minus 9.97. 24.63 kilonewton into meter. So here we got the value of bending moment, that is what? 24.63 kilonewton into meter at this point, and we know that at end supports we will have bending moment as 0. So here this is your peak point and here 0 and 0. This is your SFD, that is your force diagram, and here is your bending moment diagram for this UVL. So here we have solved this numerical on UVL, and we will solve lots of different types of numerical about this. Thank you so much.